to get us to a point where we can make drawings, right? Because that's kind of our objective with this. We want to have an interior environment, and it's going to be important to understand building sections more than anything else, and what it means to kind of cut your model in a couple different locations. So when I say a building section, how many of you know what I mean? Not many. Okay. So let's talk real. Yeah. Yeah.
Like you cut them. Or like.
Yeah, like you're cutting the building.
Yeah.
Yeah. So let's talk. Yes, it's a section. So let's talk real quick about different architectural views, I guess, and we'll get into this in more detail. But I want you to know why we're developing an interior floor and stairs. A floor plan is essentially a horizontal cut through the building. It's as if you took a hot knife and you just sliced the top off of a building at a height of usually about 4 feet high. So your doors will be cut. Any of your windows that have a lower than 4 foot sill are cut. And you get to a point where you can see all of the components that happen to rest on the floor of the building. That's a floor plan. A building section. It's essentially the same thing, but it's done vertically, where you take the entire building and you take a butcher's knife and you chop the thing in half. And it's almost like a dollhouse. I'm sure many of you have seen dollhouses where you have only one side of the building and you can see in and see all the rooms and everything that's going on in there. So it's the same premise right here. Usually these are illustrative, and then what happens is, like, the reason an architect would do a drawing like this is because then you can draw a little bubble around this area and say go to that at a larger scale. So you go to a page later on in the drawing set and it blows up and you can see a lot more detail. That's the way these drawings typically go. Even with floor plans, you go from a floor plan down to an enlarged plan where you can see some more accessories and where they're located. Then you can go even further down and you can see the actual construction of the wall, right? So in modeling, the reason I want to put a second floor in is so that when we're cutting our horizontal cuts to create a floor plan, you understand what items are going to be visible at what height or elevation of cut. And then when you take a section from the side, and the question actually came up on Monday. I believe you had asked on Monday, why don't we take the slab all the way out to the outside face? And model management, like your file management and how clean the connections are really going to determine how efficient your post-processing into a drawing is later down the road. Okay, so that's, just a little premise about why I make some of the more, finer detailed decisions that maybe I don't elaborate on as much as I should. So, let's get moving. I need to redraw this real quick because I did it differently than yours. But if you recall, and unfortunately this got erased, so this is all recap here. I add a polyline, I go to the top right corner, I'm going to go down 5 feet, then I'm going to go over 5 feet, hold shift and click, then I'm going to go down 10 feet, shift and click, and then my ortho track is set to 45. When I hit shift, you'll see it moves over, and I can click on intersect and then finish off the polyline by tracing around the rest. Okay, so something to point out here at this point that we have all arrived at. My polyline happens to sit on top of my slab, and that's because I cut off the bottom of my model. Before I made thickness on my walls. If you didn't do that, then your floor plate actually sits above the ground plane, and so your polyline is going to sit below, and you won't see it up here, you'll see it below. Is that clear? Okay. So let's actually turn this thing into a slab. So this one is pretty new to you. This is how you take line work and you create solids out of it. So we learned how to do a box, which is basically already solid. You click, and you click, and it creates a solid. But if you've got a polyline, which is essentially what you would call a profile of a solid, that's a little bit different. So we're going to do a command called ExtrudeCurve. So you click on the polyline, you type in ExtrudeCurve. CRV is short for curve. So you'll find that, for instance, when we did offset surface, it was offset SRF. And some of you had accidentally entered the command offset CRV for curve. So we're going to have ExtrudeCurve. There's also an extrude surface you see there, but ExtrudeCurve is what we want. And if you move your mouse back and forth, this is what you see. So let me explain something to you here. The reason that I spoke so much on Monday about the planar setting, whether or not you have planar turned on or off, remember that's down here. Or I'm sorry, not planar, project. Project. It's down here. And that's because you want to draw this profile in a planar environment. That means that every single point is going to be planar to one another. To illustrate it, if you looked at it from the side, which we can in a second, every point that you drop in is exactly aligned with one another, and it creates a flat plane. Ignore that. I'm not a computer. So if it's not planar, what you're going to see is something that looks kind of like this, like that. Okay, if it's not planar, it will still extrude, but you're not going to have a top or a bottom. Or if it's broken, you won't have a top or a bottom if you didn't complete the loop. So those are all very, very important things to know about turning curves into a solid. It has to be a closed loop, and it has to be planar. So let me go back. ExtrudeCurve. It asked me to select the curve, and then I hit enter. And then we have to talk about these settings. Okay, so these settings are, well, you really only need to know about 3 of them. I don't want to confuse you with the rest yet. But direction, both sides, and solid are the 3 settings that you need to be aware of. In this case, we want it to be solid. I showed you creating one that was not solid, and so it just took the profile and made it a wall, essentially. So if I want it to be solid, I have to click on solid equals no, and it'll change to solid equals yes. Notice that there are now these what's called isocurves that go across the top of the surface to show me that there's a cap there. We'll talk about isocurves in a little bit too.
So we have to write a solid yes?
Solid yes. Solid needs to equal yes.
Can you explain it?
Yeah.
Like this?
Explain which part of it.
Just the difference between solid yes and solid no.
Oh, okay. Let me pull the curve out to the side so you can see it a little better then. So I'll elaborate. What the? Where's that going? Oh, that's right. It's because they're here. Okay, so I made copies of the profile here at the end. So I copied these out to the side. You don't have to do this, but I want you to understand what that setting is. So the first one, if I do an extrude curve,
So it's going to be just faces, it's not solid.
right, so my solid setting was set to no. So it's going to extrude just the edges into a surface, or a poly surface in this case. If I want it to be solid, I need to click solid equals yes, and it comes through with a what's called a cap, essentially.
So
Okay.
we want it to be solid or not?
We do want it to be solid, yes. But let's talk about some of the other settings first as well. So extrude curve. So the other one to be aware of is whether or not you have both sides turned on. Both sides would be turned on wherever you know that you've drawn the profile in the center of where you want the extrusion to be. So if I turn on both sides, and I don't need to actually click this to show you what it's doing, but, oh, I have way too many tracks on. Hold on, I'm switching back to 90 degrees because that was getting annoying. So anyway, this is what it's going to do. It's going to pull the extrusion on both sides of the profile that I'm working on. Is that clear enough?
Yes.
And then the other setting that I want to show you is direction. So direction is important because in most cases, the direction will be predicated upon what's called a normal axis to the plane that your profile is drawn on. So we mentioned that it has to be a planar curve, a planar closed loop. So that means that it inherently has a three-dimensional work plane that it can operate on to create a solid. So the normal, if you would think of it in terms of x, y, and z, the normal is the z-axis. So I drew this plane, or rather this profile, in the x and y plane. So my z-axis is the same as the direction of my extrusion. Is that clear? Sort of, kind of. All right, so, but all I have to do, if I click direction, and I'm going to screw this up here for you so you can see what I mean. I'll turn project off as well. If I click on direction, it asks me to select 2 points, which it will then change to make that the new direction of the extrusion. So if I click here and then I click over to that corner, now my extrusion's going sideways. Does that make sense? It's the direction of the extrusion. Yeah, it's the axis, the axial direction of the extrusion. Does that make sense?
Well, so I understand the first example, like if you choose X, Y, then it's going to go Z. But the second example, where the points that you chose, where are they? Are they still X, Y, or is it like X and Z?
No, the points that I chose when I did it, I just did it arbitrary. But I wanted to show you if it accidentally goes the wrong direction, I want you to know why. That's why I'm showing you this. It should automatically, no matter how you have it turned in 3D space, it should automatically borrow the direction. But I overrode it so that you could see what it does. So if I hit enter now, see it goes back to going straight. It borrows the direction of the planar curve that you've created. So when I hit direction, I accidentally, quote unquote, set my direction to go off that way. If you find it to be doing that, all you need to do is just find vertical geometry somewhere in your file and change it. So let me do that again. Extrusion distance. If I accidentally was extruding sideways, this actually happens quite often, where you'll find that you accidentally locked on to the wrong direction here, kind of going along a plane. If that happens, all you have to do is just click on direction, find your model, and go from one edge to another that you know is in the right direction, and it'll go back. Does that make sense? So, now how do you tell it how far to extrude? Very, very simple. You just enter the ExtrudeCurve command, you make sure that your solid equals yes, and then you tell it how far. That's all. So if I want it to be 6 inches thick, all I do is type in 6 inches and I'm done. That's the full length of the command. So I'm trying to explain to you a little bit more than you need just to execute the command right now, so that you understand when something goes wrong, and it will. Happens to all of us. So that you understand what's happening. Because this one kind of throws everyone for a loop if it's not explained. Are there any questions? Yes.
Are we supposed to have a second floor there, or?
Yes, we're going to create a second floor. So in the next video, I'll create the second floor. But what I want you to do here right now, before we move on, select the curve that's in your model. Do extrude curve, and extrude it 6 inches upward.
How much?
6 inches. Yeah. Are there any questions? All right.